Our next topic is all about the mole. These are the objectives for this lesson. First, define mole and the Avogadro's number. Second is to determine the molar mass of elements and compounds. Number 3, calculate the mass, number of particles, and number of moles of elements and compounds. And lastly, explain the relationship between mass, moles, and number of atoms or molecules. Let's start by defining a mole. So a mole is just like a dozen. 1 dozen, let's say 1 dozen of eggs, it's equal to 12 eggs. So what if I have 2 dozen of eggs? How many eggs do I have? That's equal to 24 eggs. What if I just have 6 eggs? Of course, that's half a dozen or 0.5 dozen. What if I have 18 eggs? That's 1.5 or 1.5 dozen. So that's a dozen. 1 dozen is equal to 12. How about a mole? What is the mole equivalent to? It's actually equal to a very large number. It's 602 sextillion. Since it's a very large number, we commonly write it in shortcut or in scientific notation, and that is 6.02 times 10 to the power of 23. We call this number as Avogadro's number. So again, Avogadro's number is equal to 6.02 times 10 to the power of 23, which is just the shortcut or the scientific notation for this very large number. And again, this number is equal to 1 mole. 1 mole of hydrogen. How many hydrogen atoms are in 1 mole of hydrogen? It's equal to 602 sextillion hydrogen atoms. What if I have 1 mole of helium? How many particles of helium is that? That's also 602 sextillion helium atoms. So again, 1 mole is always this number. And again, this refers to the number of particles of a substance. Let's go to 1 mole of carbon. How many particles are in 1 mole of carbon? That's still 602 sextillion carbon atoms. So again, 1 mole of hydrogen, 1 mole of helium, and 1 mole of carbon have the same number. It's always equal to 6.02 times 10 to the power of 23 or 602 sextillion. Well, of course, we don't usually count atoms because atoms are very small. Instead, in laboratories, we actually weigh the substances. 1 mole of hydrogen is actually equal to 1 gram. Okay, so that's the mass of 1 mole of hydrogen. So the mass of this 602 sextillion hydrogen atom is equal to 1 gram. How about a 1 mole of helium? What would be the mass of 1 mole of helium? Again, 1 mole of hydrogen and 1 mole of helium have the same number of particles. But do they have the same mass? If you look on to the table of elements, you would see that the mass of hydrogen is approximately 1. And then the mass of helium, or the atomic mass of helium, is equal to 4. So from this mass, we can say that helium is 4 times massive compared to hydrogen. So in this case, again, 1 mole of hydrogen is equal to 1 gram. What do you think is the mass of 1 mole of helium? Right, again, helium is always times 4 heavier compared to hydrogen. So the same number of particles, but since helium is 4 times massive, so its mass is actually equal to 4 grams. Then for carbon, what do you think is the mass of carbon? If you look onto the table of elements, the mass of carbon is approximately 12. So if you compare here the mass of hydrogen and carbon, you can say that carbon is 12 times heavier compared to hydrogen. So 1 mole of hydrogen, 1 mole of carbon, the same number of particles, but since carbon is heavier compared to hydrogen, the same number of particles will have different mass. So the mass of 1 mole of carbon is equal to 12 grams. So again here, they have the same number of particles, 1 mole, 1 mole, 1 mole, but they have different mass. Let's go now to hydrogen. Again, 1 mole of hydrogen is equal to 1 gram. What if I have 2 grams of hydrogen? How many moles is that one? It's actually 2 moles of hydrogen. So you double the amount of this atoms here since you double the mass. What if I have 0.5 grams? That's half 1 gram. So how many moles is that one? That's actually 0.5 moles of hydrogen. Let's go now to 1 mole of helium. Again, 1 mole of helium is 4 grams. What if I have 2 grams? Of course, 2 grams is half of this mass. So it's equal to half of 1 mole or 0.5 moles of helium. What if I have 8 grams of helium? How many mole is that? It's equal, of course, it's double the amount of 1 mole. So the mass, or 8 grams, is equal to 2 moles of helium. Next, we have a 1 mole of carbon. 1 mole of carbon is equal to 12 grams. So what if I have 24 grams of carbon? How many mole is that? It's equal to 2 moles of carbon. What if I have 6 grams of carbon? That's half of 12 grams. So that's half of 1 mole. That's equal to 0.5 moles of carbon. Let's go now on, so as you see there, the mass number is equal to the molar mass of an element. So if you look on your table of elements, the mass of hydrogen is 1.01. So that's the molar mass of hydrogen. So 1 mole of hydrogen is equal to 1.01 grams. Then for helium, that's 4.00 grams per mole. So again, just look onto the mass number. So the mass number will tell you the molar mass of that element. Let's go on to number 1. Let's try to solve this one. How many moles are in 4.04 grams of hydrogen? So first, we need to look on the molar mass of the substance. On this case, the substance is hydrogen. So what is the molar mass of hydrogen? If you look onto your table of elements, the mass is 1.01 grams per mole. So every mole of hydrogen is equal to 1.01 grams. Before we answer, can you guess the answer for this question? Approximately 4, right? Because 1 mole is equal to 1.01 grams. So if the mass is 4.04 grams, it might be it's about 4 moles. Let's follow the process. First, write the given. The given is 4.04 grams of hydrogen. Then, we need to find out the equivalent number of moles of hydrogen. So next, we are going to go on to the solution. So here, we need to convert this mass to the number of moles. So this is conversion of units. So first, we need to write the given. The given is 4.04 grams of hydrogen. We multiply by the conversion factor. And on this case, let's use the molar mass to convert this one. So in this case, we need to cancel gram. So we put grams under here. So we can cancel it later. Then of course, we need to convert this one to mole of hydrogen. Then now we can use this molar mass. So 1 mole, that's 1 mole obviously, is equal to, so grams, so just copy this number here, 1.01 grams. Then you can multiply 4.04 times 1, that's obviously 4.04 over 1.01. The unit is mole of hydrogen. Then divide 4.04 divided by 1.01. The answer is equal to 4 moles of hydrogen. By the way, the abbreviation for moles is MOL. So the answer for this one is 4 moles of hydrogen. Let's go to number 2. How many moles are in 32 grams of oxygen? The same process. We need to identify the molar mass. Again, the molar mass is equal to the atomic mass. So the numbers are equal. So if you go on to your table of elements, you would see that the mass of oxygen is 16 grams. So that's the molar mass. So per 1 mole of hydrogen or of oxygen, the mass is 16 grams. So again, 1 mole of oxygen is 16 grams, and then here the given is 32 grams. So how many moles do you think are in this mass? So it's double, so it's approximately 2 moles of oxygen. So, but again, let's try to follow the process. The given is 32 grams of oxygen, and then we need to find the equivalent moles of oxygen. Again, we have the molar mass. Then we go on to the solution. Again, to start your solution, always start with the given. The given is 32 grams of oxygen. We need to convert this one to mole. So we need to cancel gram and convert this one to mole of oxygen. Then next we can use the molar mass. So it's equal to 1 mole over, copy this number here. So grams, copy this number 16.00. Again, grams, cancel. Then multiply 32 times 1, that's 32, over 16. Then the unit is mole of oxygen. Then divide 32 divided by 16. The answer is equal to 2 moles of oxygen. So that's for given ang mole, then given ang mass, convert to mole. Let's go now to another process. On this case, given ang mole, then identify the mass of the element. So first, the same process, we need to identify the molar mass. So what is the molar mass of neon? Molar mass of neon, if you go on to your table of elements, you would know that neon has a mass of 20.18. That's 20.18 grams per mole. So again, this is 1 mole. So if there are 2 moles, what do you think is the mass of neon? So approximately 40 point something. But let's again follow the process. The given is 2 moles of neon. Then convert this one to the mass in grams of neon. So let's go to the solution. The solution, write the given first, 2 moles of neon. Then on this case, again, we need to convert mole to grams. So here, we put the moles under this fraction since we want to cancel mole. And then convert this one to grams of mole. So here, the molar mass, so we have mole, so 1 mole. And then, when we see grams, just copy the mass here, which is equal to 20.18. The next you multiply, that's 2 times 20.18, and the answer would be 40.36. Then the unit is grams. Sorry, that's grams of neon. So the answer for this one is 40.36. Another item, number 2. Determine the mass of 2 moles of silver. Again, the process is, let's go to the molar mass. The molar mass of silver. Check your table of elements, and the mass would be 107.87 grams per mole. So every mole of Ag has a mass of 107.87. So if there are 2 moles, what do you think is the mass? So it's approximately 200 grams of silver. Let's start with the given. The given is 2 moles of silver, and then we need to find the equivalent mass in grams of silver. Then let's go to the solution. Again, for the solution, copy the given first, 2 mole of Ag, then convert this one to mass. So again, we need to cancel mole, so we put mole under the fraction or on the denominator and convert this one to grams of silver. So again, for the numbers here, we refer to the molar mass. So it's equal to 1 mole, and then the mass is 107.87, and then you do the math, 2 times 107.87. The answer is 215.74. 215.74. Cancel ang mole. The unit is grams of silver. So 2 moles of silver is equal to 215.74 grams of silver. So those are some of the problems under the conversion from moles to mass. So you can try this one and solve this one. So that's for elements. How about for compounds? Of course, compounds or molecules are composed of 2 or more atoms. Let's try to go with H2O. So what is the molar mass of H2O? The molar mass of H2O, that's of course is composed of hydrogen then oxygen. So here, the mass of hydrogen is 1.01. Then the mass of oxygen is 16. But then again here, there are 2 atoms of hydrogen, so we multiply the mass by 2 because we have 2 hydrogen atoms. That's equal to 2.02. Then here we only have 1 oxygen, so no need to multiply. So that's 2.02 from hydrogen, then 16.00 from oxygen. So the molar mass of hydrogen is equal to 18.02 grams per mole. And of course, NaCl, that's part of your activity. So again, that's the simplest way to find the molar mass for compounds. So compounds are made up of 2 or more elements. So let's say we have two moles of H2O. So what's the mass of 2 moles of H2O? So here the given is 2 moles of H2O, and then we need to find the mass in grams of H2O and then the molar mass. What is the molar mass of oxygen? Water. Again, the molar mass is 1.01 times 2. That's 2.02 plus 16. So the molar mass of H2O is 18.02 grams per mole. And the same process kanina, so we need to find write the solution. The given is 2 moles of H2O. Then, again, convert this one to grams. So, we need to cancel mole here. So, we put the mole under as a fraction. Then, above, convert to grams of H2O. Then, again, here, we use this, the molar mass. 1 mole, then the mass is 18.02. Then, we multiply 2 times 18.02. And the answer would be 36.04. That's 36.04. Cancel, cancel. The grams is grams of H2O. So 2 moles of H2O is equal to 36.04. So again, that's the same process. Ang difference lang, kaya again, we need to add the mass of every atoms in a compound or in a molecule.